So starting with a quick one here. This is just our basic a plus b binomial. We haven't thrown any extra numbers or coefficients in here just yet. And we are raising it to the 6th power, which we didn't have on our little cheat sheet version 2 slides ago. So I don't actually want to FOIL this thing 6 times. That would be hard work. So we're going to take a look at these patterns, starting with the first one. The total number of terms is always n plus 1. Well, n is 6, so I'm going to have 7 terms in this expansion. That is an ugly plus. Next thing I note is that the first coefficient and the last coefficient are going to both be 1. And the rest of the coefficients are going to come out of Pascal's triangle. So we didn't make Pascal's triangle for the 6th row. So I recommend just Googling one real quick. And kind of a quick way to get the row you care about is I want the 6th row. Find the one with the number 6 in it. That's the row we want. So 1, 6, 15, 20, 15, 6, 1. Let's see if I can remember that. 1, 6, 15, 20, 15, 6, 1. So those coefficients came out of Pascal's triangle. After that, we start playing around with the actual terms. So we want the exponent of our first term to start at n and then decrease by 1. And then we want our exponent for b to start at 0 and increase by 1. So let's do a first. Let's do a first. There we go. And we'll let a be green. So this one will have an a to the 6, because 6 is our exponent. A to the 6th. And then we'll have an a to the 5th, an a to the 4th, 3rd, squared, 1st, and then a to the 0 on that last blank. If you want to write that because it helps you out, go for it. But we don't actually need that because anything to the 0 power is just 1. And then we'll take a look at our b term. We'll make that one blue. Again, it starts at 0. We do all of our counting starting at 0 for Pascal's triangle problems. But if you don't want to write that b to the 0, no harm, no foul. That's going to increase by 1, so we get 1, 2, 3, 4, 5, and 6. So these are going to be our 7 terms. And if we had some work to do, we'd do some simplifying here. That very first one, we got a couple of 1s and an a to the 6. So that's just a to the 6, so on and so forth. There it is for all the completionists out there who want their notes to be pretty. Just note that there wasn't really much simplifying to do here. Those b to the 0 and a to the 0, I got rid of those. But we can start looking at problems that do have extra coefficients that will need to be simplified. But again, this is our goal, to take something to the 6th power without actually FOILing 6 times, because that would be a huge pain. So let's take a look at one that does have a number in it. This time we have x plus 2 as our binomial, and we are raising that to the 7th power. So as far as how many terms do we have, it's always 1 more than the exponent, so I know I'm going to have 8 total terms. Good times. And we know the coefficients are going to come out of Pascal's triangle. They start and they end with 1. And since I'm talking about the 7th power, I want to look at the 7th row, the one with the 7 in it. Remember, we do start counting at 0. That top row is the 0th row. So the shortcut there is we're always wanting to use the row with the exponent that we're taking a 2 in it. Because this is the 0 row, 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th. So we want 1, 7, 21, 35. 1, 7, 21, 35. And then the other side will be 35, 21, 7. last time? First term green, let's stick with that. We'll let the first term be green. So that first term is x. That one starts off x to the 7th, and then it's going to decrease by 1. 6, 5, 4, 3, 2, 1, nothing. That's not that interesting. What will be interesting is that second term, because that one is now a number. So we're going to have 2 to the 0 power, 2 to the first power, and so on. So we will actually have to do a bit of simplifying in this problem. 3, 4, 5, 6, and 7. So we wind up with all these powers of 2 that show up in this binomial. It's important somewhere in the middle you kind of double check, am I doing this right? 3 plus 4 is 7. So we know that that one's working out. We want the sum of those exponents to always be the exponent we're starting with there. So 3 plus 4 is 7, 2 plus 5 is 7, so on and so forth. So that checks out, and that's nice. So simplifying this is a bit more work. It can be helpful to, before you go from blanks to the polynomial itself, just do this kind of work. We know 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, so on and so forth. 16, 32, 64, and 128. Eventually, you'll have multiple numbers to deal with, so it's nice to see everything that's going to wind up in your calculator before you go down and start writing that whole expanded polynomial. Because in this case, you see clearly what we really want to do is 35 times 16, for example. So, yeah, just a little shortcut to help that one out. So let's go ahead and simplify this sucker. We want to start with that first term. Note that 2 to the 0 is 1. That's just a 1. So that first term is whatever. It's x to the 7th. Because everything else there is a 1. After that, things get more fun. Taking a look at the second term, we have a 7 times 2, which is 14. And then there's an x to the 6 tagging along. After that, we've got this 21 and that 4. 21 times 4 is 84. And we have an x to the 5th. Then our numbers are going to get really big. Next term, we've got a 35 times 8, which is 208. Jumping down to our second row, we have a 35 times 16, which is 560. And then we'll have a 21 times 32. 21 times 32, 672. Will he have enough room? 7 times 64, it's 448. Looks like I will not. Sad day. And then last but not least, 1 times 128 is 128. Woo! Again, way faster than foiling 7 times. We're just using a pattern to help us build up that polynomial there. And then you can do whatever you want with this polynomial. You know, like factor it. Oh wait, that's already done. It's got 1, 0 at -2, multiplicity 7. Quite nice, quite nice. Or you could graph it or do whatever else you want with this mess. So we had an easy example. Here we have kind of a medium example because there were numbers involved. Take a break, stand up, stretch. We'll come back to the hard examples in the next video.